So welcome to electrical machine lecture. In the previous lecture, uh, we have discussed the series field test on the DC series motor. So now today we are going to see one example on the field test. The example is such that the test on two coupled similar tramway motors with their field connected in series. So for the tramways, generally DC series motors are used. So instead of directly mentioning the DC motor, here tramway motors word is used. So tramway motors with their field connected in series gave the following results when one machine acting as a motor as and other acting as a generator. So this is the motor results. Armature current 56 ampere, motor voltage 590 volt, voltage drop across the field winding is 40 volt. For the generator, armature current 44 ampere, armature voltage 400 volt, field voltage drop 40 volt, armature resistance RA is equal to 0.3 ohm. So from this one, the circuit diagram has been drawn as early in the earlier lecture, this diagram has been discussed. So here this is mechanically coupled. These two motors are mechanically coupled. So this is mechanically coupled. The series winding of motor as well as generator is connected to the supply voltage, and one acting as a motor. Say this is acting motor and this is acting as a generator. So what are the specification for the motor? Armature current is 56 ampere. So the same current is going to flow from the field winding. So here this is 56 ampere. Motor voltage, the voltage across motor. So this is the voltage across motor. It is mentioned. So this voltage is equal to 590 volt. 590 volt. Whereas the voltage drop across field winding is 40. So up to this voltage is 40 volt. So voltage drop across series field winding of the motor is 40. From the generator side, armature current is 44 ampere. So this current, armature current, as it is delivering, it is a 44 ampere. Armature voltage, the voltage across the armature, it is voltage or terminal voltage across load resistance is 400 volt. The field voltage drop, the field of this generator is this one. So here the voltage drop across the field winding is 40 volt. Since the motor is similar, same voltage is going to drop across the field winding. Okay. So an armature resistance RMA of RA for the both the machine, RA is given as it is 0.3 ohm. Now it is possible to calculate the field resistance. So RSE is equal to 40 divided by the current which is flowing. Either you can calculate 40 divided by 56 and the same current is going to flow from here. So 40 divided by 56. So it is equal to 40 divided by 56. So the armature field resistance is 0.714 ohm. So these are the values from this one. Okay. Now one more thing. This is 590 volt. and this is 40 volt. So the total voltage across the circuit, the voltage across the circuit should be 590 plus 40, it is 630 volt. So here it is from the given data, we are able to calculate this one. Okay. Now total input is equal to, say this is voltage V and this is current I. So V into I1. So this is I1. So it is I1 and this is I2. This voltage across motor is V1 and this voltage across this one, it is say V2. Okay. So V into this one. So it is 630 into 56, which is equal to 35,280 watt. So this is the power input to the set. Now output of the generator. Output of generator, it is V2 I2, which is equal to 400 volt multiplied by 44 44. So it is equal to 17,680 watt. So this is the total power input, total power input, total power output of the set. So the total losses. Now first we will calculate the, sorry, this is 17,600. This is 17,600. Okay. Now the total losses, total loss in both the machines, which is equal to total input minus total output, the output of the generator. So it is 35,280 minus 17,600. So the total losses in both the machine is 17,680 watt. This is the total losses in the machine. Now, if you subtract the copper loss in the armature of motor as well as the generator, so the remaining losses is the stray losses. So first we will calculate the total copper loss, total Cu loss, which is equal to. So it is the current in the armature circuit, in the field and armature circuit is, say it is resistance, say I1 square, the resistance of armature Ra plus the series resistance of motor and series resistance of generator. So this is RAC, this is RSE. So by adding these two, so it is twice RSE. So this is the copper losses in this circuit plus copper losses in the DC generator. So it is I2 square Ra, armature resistance of the generator. Here the currents are different. So it is 56 square into 0.3 plus 2 into 0.714 bracket complete plus 44 square, the current in the generator, multiplied by 0.3. So the total copper losses is 6006 watt. So now the total losses we know. So stray losses for both the machine, stray loss for both the machines is equal to total loss minus total CU loss, which is equal to 17,680 minus 6,006. So it is equal to 11,674 watt. Now stray losses per machine, stray loss per machine, it is equal to 11,674 divided by 2. So WS is the stray loss. It is equal to 5,837 watt. Okay. Now we are going to now this losses are available. It is possible to calculate the efficiency of motor. Efficiency of motor. So for the motor input, motor input is equal to the voltage across motor, that is V1 into I1, which is equal to 590 multiplied by 56. See here, the voltage across motor, this is the series motor, series field winding and armature winding. So the voltage across motor is V1, that is 590, and current drawn by the motor is 56 ampere. Here this is the 56 ampere. So it is equal to 33,040 watt. This is the power input. Now motor CU loss, motor losses is equal to I1 square into bracket RA plus RSE, only one series resistance, plus stray loss WS. So it is equal to 56 square 0.3 plus 0.714 plus stray loss is 5,837 watt, and total losses is equal to 9,017 watt. So this is the total loss. Now once the total loss and total input is available, motor output the difference of these two, that is motor input is 33,040 minus 9,117, and motor output equals to 24,023 watt. This is the motor output. So motor efficiency percentage, motor efficiency equals to 24,023 divided by 33,040 watt into 100. So motor efficiency is 72.7%. This is the motor efficiency. Now, second is the generator. Generator efficiency. Of generator. So here generator output is equal to V2 I2. It is 400 multiplied by 44. So output of the generator is 17,600 watt. Whereas total losses is equal to armature Cu loss I2 square Ra plus field Cu loss I1 square Rse, because the series winding is connected in motor, plus Ws. So it is equal to 44 square into 0.3 plus 56 square into 0.714 plus stray losses 5,837 watt. So total losses is equal to 8,658%. Sorry, this is the watt, 58 watt. Now output is available, losses is available. So efficiency, percentage efficiency of generator is equal to output 17,600 divided by output plus losses 17,600 plus 8,658 multiplied by 100. So efficiency of generator equals to 67%. Now, if you remember, the efficiency found by Hopkinson test for the motor and generator is somewhat similar because the machine is similar. So definitely the efficiency must be near to each other. Whereas here also there are two similar motors. The capacity is same, characteristic type is same, even though the efficiency of machine which acting as a motor is 72%, whereas the machine which is acting as a generator is 67%. The reason is that the first machine which is acting as a motor, it is in the normal condition. We are supplying the rated voltage across the motor, that is series plus one. Whereas for the second machine, it is acting as a separately excited generator. So here the mode of operation will not be the same. Mode of operation means here the machine which is acting, the way it is acting, one is acting as a series motor. If suppose the second acting as a series generator, then it is okay. But whereas the one acting as a series motor and second acting as a separately excited generator, that's why the efficiency have a some larger value. So thank you for this lecture. And this is the end of testing of DC machine.